Good morning, everyone. This is Neha Sharma from Department of Mathematics, ITM University. We have so far studied many of the topics of this unit. Okay, so we have seen what set theory is, then we have seen what relations are, then we have seen what functions are. We have seen certain types of functions also. Now, this is the last topic for functions. Today, we would see what recursive functions are. Okay, so let's start the video for recursive functions. Let's first see the outlines that we are going to follow in this particular video. So first we would see what are the prerequisites for recursive functions. Then we would see what recursion or recurrence process is. Then we would see the definition for recursive functions. Okay. Then we would see certain examples for recursive functions. Then we would have some exercises. Then we would see certain learning outcomes and research skills. Okay. So let's start with the prerequisites. Okay, for recurrence or recursion or recursive function, we should know what relations are. Then we should know what functions are also. Since we have discussed all of this in the previous videos, if you have not watched those videos, please go back and see the video on functions and then come back to this. Okay, so for this particular video, you should obviously be knowing what factorial is, uh, what sorry, what factorial is, uh, and also what functions are and what relations are. Okay, so we have seen what prerequisites we would need over here. Now let's see what the process recursion actually is. Okay, now let's read the definition and then we would understand what recursion process is. So it is very difficult sometimes to define an object explicitly, but it may be easier if you define that object in terms of itself only. Okay, so this process is known as recursion. Now, what is recursion? If if an object is being defined in terms of itself only, then that process is known as a recursive process or recursion. Okay, and so, suppose we have taken a function, let's say a factorial. So, there, what happens is the factorial of n plus 1 is the factorial of n into n plus 1. Okay, I hope I'm right. Okay, so in that process, what is happening is that the factorial of the next number is being dependent upon the factorials of the previous numbers. Okay, if we define the factorial in terms of itself, if you want to define that, okay, that way. So, what recursion process is? If a function use itself for finding the value of the function at the next step. Okay, so that process is recursion. Okay, now let's read this. The process of recursion involves defining the value of the function by using the other values of the same function. Okay, so basically, if you have values at some particular points and then you want to get the value for the next particular value, okay, for a given function, then that process is recursion only. Okay, now let's see what recursive functions are. Okay, we have seen the process recursion. Okay, now we would see what recursive functions are. So let's see the definition. A function on the set of non-negative integers. First, you need to remember that for a function to be recursive, the set of domain set that we should have would be the set of non-negative integers. Okay, so it is being applied onto the set of non-negative integers only. Okay, so a function of that sort is said to be recursive if the value of the function at successive integer can be given by the value of that function at the previous integers. Okay, so basically, if we have defined a function over non-negative integers, over the set of non-negative integers, and the function value at a particular point, okay, the function value at a particular point can be find by using the previous values of that particular function, then that function is known as recursive function. Okay. Now, in recursive function, if you want to see a function is a recursive function or not, or that, then you have two steps. The first step is basis step, and the second step is recursive step. Okay. In the basic step, what you have to do, you have to write the value of the function at 0 or any particular value. So basically, uh, okay. So you have studied what differential equations are. Okay. So in finding out the solution for the differential equations, you obviously have used initial value. You have done some initial value problems also, है ना? So here also, this value that we are doing or looking for in the basis step is the initial value step only. Okay, so here you need to have a initial value. You need to have an initial value for the function that is being already given. Okay, so it should be at 0 or at any particular value. Okay, then the second step is the recursive step. This is the main step. There, what you have to do, you have to use the value of the function at a particular integer, and then you have to get the value at the next integer. Okay, why we're talking about integers? Because the set of domain is the non-negative integers only. Okay, so you have been given with the value at a particular integer, either 0 or 1 or 2 or any of the integer, and then you would use that particular value in order to find the next value, and then all the previous values in order to find the next particular value. Okay, so that kind of function is known as the recursive function. Okay, now if we take the example of a factorial function, then how a factorial function can be written as a recursive function? It can be written as f of n plus 1 is equals to f of n into n plus 1. Okay, so this can be written like this. Okay, you can obviously write it somewhere and uh, uh, see if that's correct or not. Okay. Now let's see an example of a recursive function. Okay. So suppose a function f is defined recursively by f0 is equals to 1. Okay. Now f0 is 1 is the basis step. Okay. Is the basis step that you're given with. Now for the recursive, sorry, for the recursive step, the function should be given, okay, in terms of itself only. So here the function is being given in terms of itself. That's why that is the example of a recursive function. Okay, so f of x plus 1 is equals to 3 into fx plus 1. Okay, there can be a case where the function value at the next step uses two or three or many values of the function at the previous stages. This also can be the case. Okay, but we have taken the simplest example of all over here. So f of x plus 1 is equals to 3 into fx plus 1. Okay, here you have been given with the value of f at 0. Okay, that is 1. So you have to compute what f of f at 1 and also f at 2. Okay, so for finding the value of f at 1, what you have to do, you have to put this 1 over here, so it would be, sorry, for finding the value of 1 you have to put 0 over here. Okay, so it would become f of 0 plus 1, which is f of 1 is equals to 3 or 3 into f of 0. Okay, now where to get the value from for f of 0? It is given in the question, so f of 0 would be put over here, so it would become 3 into f of 0 plus 1, which is 3 into 1 plus 1, which is 4. Okay, so we have got the value of f of 1 as 4. Similarly, we can get the value for f of 2 also. Okay, here, but here, what would be used? You would use the value of f of 1. You would not use the value of f of 0. Okay, you have to remember that. Okay, now this was a very simple example. That's why it looks very trivial to use. Okay, but when you go to a higher example, a more complicated example, then obviously you would understand how recursive function is very much useful. Okay, and now let's see recursion in programming languages. Okay, now recur- why I have put this slide over here is because you all are computer science students. Okay, so most of you are like computer science students, so you would obviously you study programming languages, and most of you have already been studying programming languages. Okay, so recursion, so let's see, recursion is a very useful tool in okay, let's Wait over here. Okay, so when you study programming languages, what happens is that you have to obviously write programs. So there, you write programs for certain functions that obviously. Let's do this. Okay, so there you use certain programs mm, where um, where you you call a function in itself only. So there, that's a process of recursion. That's a example of recursion. Okay, so whenever you are writing a program, okay, and if you are using a function and a function calls itself um, somewhere, then that's a process of recursion, okay, that you use in programming languages. So if you take the example of factorial or Fibonacci series, then there, what can happen is, okay, please make it correct. So it is f of n plus 1 is equals to f of n into n plus 1, okay, in the factorial part, okay. So if you write the code for f of n plus 1, sorry, n factorial, then there you would obviously have to call n minus 1 factorial for finding the value of n factorial. Okay, so this kind of so in this these kind of functions you obviously use recursion programming languages. So basically, since you're all computer science students and you obviously have studied any of the programming languages, so please write the code for n factorial and Fibonacci series, and in terms of recursion only. Okay, so basically write the code, um, and you and make the function call itself. Okay. Okay, now let's see what Oxford Dictionary has to say about recursion. So it says the application or use of a recursive procedure or definition. Okay, so according to Oxford Dictionary, what happens is that the application or use of recursive process or definition is recursion. Okay, so I hope that's pretty much clear up till here. Now let's see what primitive function is. Now primitive function is altogether a different topic. Okay, but that was we just have to study the definition. That's why I have add, added that in this topic only. Okay. So let's see the definition first. A function is called a primitive function to a function if it can be found from the reverse process. Okay. Now, what do we mean when we say that it can be found from the reverse process? So let's take an example first. Let fx is equals to x to the power 2. Okay, so x squared, if you differentiate it, so basically you have operated it, okay, and the operator is differentiation. So if when you have differentiated it, it would become 2x. Okay, now obviously if you differentiate 2x also, it would give you 2, and then obviously you would differentiate that also. Okay, that's a chain process. Okay, now obviously there would have been a function which would have been differentiated in order to get this first function. Okay, so there can be a function that can be differentiated, that would have been differentiated in order to get fx. Okay, so that function would be known as the primitive function. Okay, so primitive function is a function that can be got from the same process that we are doing in a particular question and example. Okay, but previously. Okay, so let's see what is the function for this what is a primitive function for fx. It would be x to the power 3 by 3. So if you differentiate x to the power 3 by 3, it would give you x to the power 2. Now we have to see if the primitive function is unique or not. Okay, so no, primitive function is not unique, because if you take the example, okay, the same example. So here, if you take the another function which is x to the power 3 by 3 plus 4, so that would also be a primitive function for this particular function. Okay, please see again, x to the power 3 by 3 plus 4, that function would also be a primitive function for x to the power 2. For that matter, take any of the constant instead of 4, okay? It would work as a primitive function for this particular function, okay? So basically, there is not a primitive function, there is a family of primitive functions for a given function. Okay, so if this is the given function, then there is a family of primitive functions to this function. Okay. Mm, okay, so I hope primitive functions is very much clear by this. Okay, so now let's move forward to the exercises. Okay, this exercise part is very much important. Please do that. Okay, otherwise everything that we have studied would go waste. Okay, so give an example for recursive function. Please think about an example of a recursive function. Don't just look at a book or maybe on internet source and do that. Okay, so please think of an recursive function example. Okay, now the second question is write a dummy program for the function n factorial. So maybe don't go to the C language and then write a program or things like that. But at least write a dummy program for n factorial where the function calls itself. Okay, so basically you have to write a program for n factorial as a recursive case. And also for Fibonacci series, you can write a demo program as a recursive case. So basically, uh, a case where the function calls itself. Okay, so please do that. What are the learning outcomes? We have seen the concept of recursive function over here. Okay, we have also seen how that's very much relevant and useful in computer science field. Okay, and also we have seen a separate concept of primitive functions over here. So, what's the research scope? Since the topic that we have studied today is the recursive functions, is the recursive functions, which has immense usage in computer science field. So, obviously, you can use these recursion functions in writing programs, and uh, in that way, you can obviously use that somewhere else also. So, thank. Okay, now let's see the references also. I've been telling this all the times that CLU is the best book for Discrete if you want to purchase or if you want to see. Okay, this Kenneth H. Rosen also you can refer, and also there are certain books of Indian authors that also you can refer. Thank you so much for watching the video, and please do the exercise at home. That would be very helpful for you to understand the topic very nicely. Okay, so study hard and be safe.